Select the best reagents to accomplish the following transformation. So we're starting with an aniline, and we are ending up with a benzene that has a chlorine and a nitrile group meta to each other. So what we want to do with these aromatic syntheses is go about this logically. So rather than completely working backwards, I advise making a list of some key things that we need to pay attention to. So directing effects are always very, very important in our aromatic syntheses. So we want to take a look and say, where are these substituents relative to each other? And as we already mentioned, these are meta to each other. So I'm going to take a note that we've got this meta orientation. What that tells us is at the time that the second group, whatever the second group is, whether it ends up being the chlorine or that nitrile, at the time the second group is introduced to the ring, we need to have a meta director present, because it's always a substituent that is on the ring already that directs the incoming nucleophile. So in terms of strategy, what we want to do then is list the reactions that we need to do based on these groups, and then considering the fact that we want them to end up meta to each other, that will allow us to put these reactions in the right order. So let's go for the obvious first. We see a chlorine on here. We have to do chlorination at some point. The nitrile may not be as obvious. There's not a direct EAS reaction that we can do to add that on there, but we can add it via the Sandmeyer chemistry. So that's taking a diazonium salt and treating it with a copper salt. So in this case, it would be copper cyanide. So we definitely need to do this two-step process where we take the amine and transform it into the diazonium salt. So we need to make the diazonium salt. And this needs to be followed up by treating it with copper bromide, or sorry, not copper bromide, copper cyanide, to make that cyano group. So, and this is a two-step process that are going to have to go together. So we want to think about the different groups. So the amine that we start with is an orthopara director. We can't stop at the diazonium salt and add something else to the ring, because when you add something to the diazonium salt, it's going to be displacing the diazonium. So we don't need to consider that. We can consider the chlorine, which is an orthopara director. And then if we look at this nitrile, it is an electron withdrawing group, the same as we've seen with carbonyls. So this is a meta director. So finally, we found a meta director. So what that tells us is that we need to get that cyano group installed first, and then we can add the chlorine. So starting from here, we need to do this series of reactions first to get the nitrile on there, and then we can do the chlorination. So to go from this amine to the nitrile, it's a two-step process. So we're going to want to first convert this into a diazonium salt. So that is using sodium nitrite, hydrochloric acid at 0 degrees Celsius, and that will give us the diazonium. And then we don't have a choice, we gotta do these sequentially. Then if we treat this, so it's a chloride ion. If we treat this with copper cyanide, then we will replace that diazonium with the cyano group. And then with our cyano group installed, we've got the meta director, we can do the chlorination, and that will put the chlorine on the meta position, which is what we're looking for. So if we take a look at our options down there, we're looking for one where we're making the diazonium, then adding the copper cyanide, and then doing the chlorination. So that looks like B, right? So making the diazonium, converting it into the nitrile, and then chlorinating, right? So really similar conditions exist in B, so it has the right sets of reagents, just in a different order. Or so if it's B, this should actually be D, huh? We really need to have 4 different options here. So D, if we were to do this set of conditions instead, we would end up with a different result, right? So we would probably end up putting chlorine at more than one orthopara position and then converting that to the cyanide. So we wouldn't get this meta orientation.